Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Exponential Function Basics. Concept number 4, Exponential Growth Function. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. What we're doing here is super effective. I'm coaching you to turn your wants and desires of getting an A or perfect test scores into a brand new paradigm. I want to include everyone who needs a boost in Algebra 2, and if I could stick every single math student with a syringe containing a healthy dose of eye-opening awareness of their inner mathematical genius, I probably would. So inbox me at memedicine@gmail.com to purchase the complete cram session. You have lots of friends, classmates, and colleagues who are also taking Algebra 2 with you, and they could really benefit from purchasing the entire cram session as well. So tell them to inbox me at memedicine@gmail.com so that they too can order the complete cram session. You'll be glad you spread the word because they'll make great study buddies. And last but not least, the concept of cramming often has a negative connotation, but what people are actually thinking of is hurrying, which is a result of fear and can consequently be destructive. We're not hurrying, we're cramming, and there's a huge difference. Hurrying is jam-packing tons and tons of unorganized information into your mental, spiritual DNA over a tiny amount of elapsed time, okay? Whereas cramming is taking quantum leaps in your understanding in an organized way in what seems to have been a really brief instant. So let's delve into the concept of exponential growth. Basic concept number 4. Exponential functions. For the exponential function y equals b to the x, draw a growth curve. Definitely press pause if you need to, and I'll give you a moment to think. All right, let's get into it. And if you didn't figure out what the curve is, if you weren't able to draw, that's completely fine. Let's tackle this together, okay? All right, so in the general format for the exponential function, y equals b to the x, we have b, the constant, x, the exponent. You might have heard me say power. That's actually wrong because y, or the result, or the dependent variable, is the power. Oftentimes, for an exponential function, we call the exponent or the independent variable the power, but it's actually wrong. Let's say we were to plug in 2 for x. The way that we would express the result y is we would say y is the second power of b. Okay? All right, so yeah. The shape of the graph, okay, is going to depend on this constant, or the base b, okay? So for b is greater than 1, we're going to have our y-intercept here at 0 because b to the 0 power, or any base to the 0 power, is always going to be 1, okay? And when you draw the graph, you're also going to have a horizontal asymptote at y is equivalent to 0, aka the x-axis, or y equals 0. And as you can see, y, or our output or dependent variable, is increasing as the independent variable, or the value of x, increases, okay? And this is the classic exponential growth curve. So this is our answer. But before we exit and skedaddle, I just need to cover a few points with you. Be sure to understand that here we're only concerned with positive values of b, okay? So we wouldn't want a negative value of b. And why wouldn't we want a negative constant? Well, let's just use an example to elucidate why we don't want negatives. No negative b's allowed, okay? And let's say, for example, you were to insert a negative number. We're going to take -2. Well, what would happen if you were to plug in the value 0.5 for x, which can also be written in fractional form? And you know that the way you interpret this is you raise the base to the numerator and you take the nth root of the denominator. So what you're going to have is negative 2 to the first power. You're going to take the square root or the second root of that, okay? And what you wind up with is two problematic things. First, you wind up with an imaginary number because the square root of 1 is the imaginary number I, okay? And you also end up with radical 2. Well, radical 2 is not necessarily imaginary, excuse me. It is irrational, meaning that if you were to try to evaluate it as a fraction, it would never simplify. And if you were to try to evaluate the actual square root, it never terminates. It's like a never-ending decimal. You're going to get an answer of 1.41, like 1356 or something like that, okay? And then it goes on and on and on. So this is a no-no. We don't want this. And another thing that you don't want b to be is 1. And why is that? Well, let's say you plug in any value for x, whether it's negative infinity all the way to infinity, what you're going to get is 1. Because 1 raised to any power is just 1. And what you'll have is a flat line. And that's a concern because when b is 1, it yields something that's not a one-to-one function. Rather, it's a one-to-many relation. And if a horizontal line were drawn through this flat line, well, it would touch the curve at every place. This means that the y equals b to the x relation would return the same output value or dependent variable for all the independent variables inputted along the x-axis. Okay, so these are just 2 points you want to keep in mind. No negative b's and no 1 for your base constant. And visual inspection also reveals that the domain is all real numbers. That's all counting numbers along the number line. And visual inspection also reveals that the range, or the output based on your domain, is anything bigger than the horizontal asymptote y equals 0. Therefore, the range is y is greater than 0, or all positive numbers. And note that positive numbers don't include 0. 0 is like a neutral point. It's neither negative nor positive. All right? Thanks for tuning in. And as you were able to see, intellectual comprehension of this material was not difficult at all. Okay? And after purchasing this complete Cram session, by inboxing me at memedicine@gmail.com to order, you'll be able to answer a battery of questions about any Algebra 2 concept. So good luck studying, and again, thanks for tuning in.